All right, so this is 1.4 continued. Still dealing with properties of radicals. We're going to simplify the following expression by rationalizing the denominator. What does that mean to rationalize? That just means to get rid of these square roots or cube roots in the denominator, okay? So how would I get rid of a square root of 5y? How do I get rid of that square root? Well, what does the 5 need to get out of the house? Okay, so that could be what you ask yourself. Well, the square root tells me that I need 2 copies of itself to get out. All right, well, right now I only have 1 5. Okay, so what can I multiply this by to get rid of this square root? To get it out of the house, how many 5s do I need? I need 2 of them. Well, if I've got 1 here, well, I'm just going to put 1 more right in there, okay? And same with the y. How many y's do I have? Right now I have 1. I need 2 to get rid of that square root in the denominator. So how do I do it? I multiply by another one, okay? So whenever I do this, what's going to happen? Well, if I only multiplied in the denominator by this, I would be changing the problem. But in order to keep the problem the same, I'm going to multiply not only the denominator by a square root of 5y, but also the numerator. So whatever I write down here in the bottom, I need to write in the top too, okay? So let's rewrite this. So this is x multiplied by 5 square root of 5y. And then in the denominator, what do I have? I have a square root and a square root, okay? So we're assuming these pieces are both positive, and if they're both positive, we can combine them together, all right? And you're gonna see the magic in why we did what we did. So what do I have? 5 times 5, okay? And then I have y times y. Why is this good for us? Well, let's think about it. The top stays the same. I can't take a 5 or a y out of my radical. Okay. However, the denominator, what's the square root of 5 times 5? Well, 5 times 5 is 25. The square root of 25 is 5. Good. What about this? This is y squared. The square root of y squared is just y. All right, as long as these variables are positive, we're good to go. All right, so we can assume that unless otherwise stated. All right, so this is rationalizing the denominator. Now there are no radicals in the denominator here. All right, let's try another one. This one I think is a little tricky, and that's why I want to go over it and wanted to do this one second. Okay, so say we had the cube root of 32 divided by the cube root of 12. Now, why is this one tricky? Okay, so a lot of students are really good with doing the square root because basically you just look and you say, oh, I have a square root 5y here. I need to multiply top and bottom by what's right here, and I'm good to go. That's usually pretty easy. Now, this one's a little trickier, but as long as you think about what you need to get rid of the radical, then it doesn't matter what your index is here, you can figure it out. Okay, so what do I mean by that? Well, with the cube root, how many copies of itself do I need? Well, I need 3 copies of itself, okay? And we can simplify later, but this is the easiest way to get this problem knocked out. So right now I only have 1 12. How many do I need to get out of the house? I need 3 12s, okay? So I need to multiply by a 12 and then another 12, okay? And so I do that on the top and bottom. That way I don't change the problem, okay? And so we have the same number here. All right, so let's see if we can do some simplifying here, okay? So in the numerator, I have a cube root and I have a cube root. So it's the cube root of what? 32 times 12 times 12, okay? And then in the denominator, I have the cube root of 12 times 12 times 12. Now this is pretty nice. Why is this nice? Well, 12 times 12 times 12, that's 3 12s. So I'm going to help you out here. The denominator is 12. And now we've rationalized it. Now we've just got to simplify the top. Now before you go and get your calculator and multiply all this out, I want us to break this down a little bit more. Okay, so 32 times 12 times 12. So 32 breaks down to 8 times 4, okay? 12 is 4 times 3, and then the other 12 is 4 times 3. Okay, so right off the bat, I see a 4, a 4, and a 4. That's 3 4s, okay? That's good. That means I can pull a 4 out. Okay, uh-oh, might have messed up my marker there. All right, and then also 8 breaks down to 2 times 2 times 2. So that means I can also pull a 2 out, okay? And what do I have left? A 3 times a 3. So cube root of 3 times 3 is 9. So this ends up being 4 times 2. Oh, this is like a double line, okay? That's 8 cube root of 9 over 12. Now 8 and 12, that can reduce. So let's see, a 4 can come out of both of those. So that's 2 cube root 9 over, well, 3. Okay? And this will be our answer right here. Now, last one is a little tricky, but I think we'll be able to get it. Okay. So I'm still doing the same thing, simplifying. We're going to rationalize the denominator, but say I have like a square root of x over the square root of x minus the square root of 3. Okay. Now, when I see a plus or a minus in the denominator and we have square roots business like we have here, I always think multiply by the conjugate. The conjugate pair for this is, instead of square root x minus square root 3, it's going to be square root x plus square root 3. We exchange the negative for a plus, and if this was a plus, we would make that negative. It's opposite sign in the middle here, okay? Now if I multiply on the bottom, I need to multiply the same thing on the top. Keep it the same expression. Okay, so the top is pretty easy. It's square root of x multiplied by this whole quantity here, square root x plus square root 3. And then the denominator, we're going to have to do double distributing, or sometimes known as FOIL. First, outer, inner, and then last. Okay, so if I multiply the first, that's square root x times square root x. And then plus outer, that's square root x times square root 3. Okay. Inner, negative square root 3 times square root x. And then last, okay, negative square root 3 and then square root 3. All right, so now we need to do some simplification here, okay? What is the square root of x times the square root of x? Well, all that is, here's a little side work for you. This is the square root of x squared. Well, how many x's is that? That's just x, all right? If I distribute in the numerator, I get square root x times square root x. Well, we just said that that was x. And then I have square root x times square root 3. So square root x times square root 3, what is that? That's just the square root of 3x, okay? Now in the denominator here, what do I still have the same thing going on? I've got x, square root x times square root x, which is x. And then square root 3 and square root x, we just combine. I get square root 3x. And then I have a negative square root 3 and a square root x, so that's minus square root 3x. And then I have a negative square root 3 and a positive square root 3. Well, the negative is just negative, but if I have a square root of 3 multiplied by a square root of 3, you can check this in your calculator. But what is that? That's really kind of like saying square root of 9, which is 3. So this gives me a negative 3. What's going to happen here that's so great about multiplying by the conjugate? These terms should cancel your middle terms here. And why is that good? Because that gets rid of the radical in the denominator and rationalizes the rational expression. So this is x plus square root 3x divided by x minus 3. Boom.